So we're going to look at our last lesson in chapter 11, or unit 11, and it's on the distance formula. It's another application using radicals. And it's an extension of the Pythagoras Theorem. Yes? We're going to do homework after lecture today. So hold on to your thoughts for your homework. So 11-9, the distance formula. If you don't have graph paper by now, you must have graph paper starting Monday. We're going to be graphing a lot on Monday. And you need to have graph paper to take those notes. You're supposed to have it right now, but make sure you get it. Does anybody remember learning the distance formula in middle school? Everybody in here should have had it. It is part of your 8th grade standards. Okay. Here's what the distance formula is used to find the distance between two ordered pairs in the coordinate grid. So the formula is as written: y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. The x sub 1 and y sub 1, they belong to ordered pairs, so you would have two ordered pairs, x sub 1, y sub 1, and x sub 2, y sub 2. You need to memorize this formula. It is derived from the Pythagoras Theorem, which I'll show you here in a minute why and how. You're basically taking the difference between your y's, the difference between your x's, you're squaring them, and you're adding them together and taking the square root. It really doesn't matter which comes first, x sub 1, y sub 1, or here. Because if somebody switches them around, one of you is going to get a negative, one of you is going to get a positive. When you square a positive or a negative, doesn't it always turn out positive anyway? And those differences are going to be the same. For instance, let's just say that your y's are 1 and 3. What's 1 minus 3? Negative 2. What's 3 minus 1? Positive 2. Absolute value-wise, don't you get the same number 2? And if you square positive 2 or square negative 2, you're still going to get 4. So it really doesn't matter. And it doesn't matter if you put your x terms here first and your y terms here, so long as you're taking the difference. All right, so go ahead and draw in a coordinate grid and make it, about a 5 by 5 or a 4 by 4. We'll go with 4. And I want you to plot the following points. I want you to plot 3, 3. And I want you to plot the point negative 3, negative 2. What we are finding is the diagonal distance between these 2 points. I can't actually count that distance because I'm going diagonally across the squares. Now there's a couple of ways you can actually find the distance for this. As far as our formula goes, you can choose, it doesn't matter which point is point 1 and which point is point 2. Remember that these sub 1s and sub 2s just differentiate the fact that this ordered pair belongs to point 1, this ordered pair belongs to point 2. I don't care which one you make point 1 or point 2, but I do want you to label them as x sub 1, y sub 1, x sub 2, y sub 2. So let's say that I put this as x sub 1, y sub 1, and this is x sub 2, y sub 2. Again, it doesn't matter. Now, yesterday, you learned how to use Pythagoras Theorem. Couldn't I take this diagonal and make it my hypotenuse? And couldn't I create a right triangle like this? There's a right angle. Now I can actually count these distances here. What's the distance from 3, 3 down to here? Count squares. How many squares? Don't count points, count squares. 1, 2, 3, 4, 5. So this is a distance of 5 units. What's this one? That one's 6. So that has a distance of 6 units. So there's two different ways that you could solve this. So we've got way 1, and in my notes I have these reversed. Don't let that bother you. Way 1, we're going to use Pythagoras Theorem from yesterday. Now the reason why you learn the distance formula is because imagine if my points were like, I don't know, 24, 60, and negative 50, negative 25. Would you want to plot that and make a right triangle and then try to go from there? No. So sometimes you're going to want to plot it and find your right triangle and go from there. Other times not. So Pythagoras' theorem was a squared plus b squared equals c squared. This is my a and my b because they're my legs. I'm trying to find c. So I'm going to put in for my a and my b, doesn't matter which is which, 5 units and 6 units. What's 5 squared? So we get 25 plus what's 6 squared? 36 equals c squared. And then, so right here, this technically is the difference between your y values, by the way, this vertical distance. And this horizontal distance is technically the difference between your x values. See how they've been squared, and added together? What am I going to get ready to do once I add these together? Right. So did we get 61 equals c squared? And then we go and take the square root. Notice that this is a square root. So they took Pythagoras' theorem and they solved for c. And they realized that a and b represents that vertical distance between the points and the horizontal distance between the points. And so is 61 prime? Yes. So c is equal to the square root of 61. That's the distance between those 2 points. So you could still do that, but let's go ahead and do way 2. We're going to use the distance formula. So I'm going to take my formula right up here, and I'm going to rewrite it, but I'm not using the x and the y's. So I'm just going to use what I call a template. So d equals, don't forget that square root. That's the biggest mistake, is that you leave that square root off and get a little lazy. But I'm going to have 2 parentheses squared with a minus here, plus here, and a minus there. Bless you. Then I'm just going to replace inside the parentheses the 4 numbers that belong to the ordered pairs. So y sub 2 is 3. Y sub 1 is negative 2, so I'm subtracting a negative 2. And the reason why I have you put the negatives in first is because in this case, I have a lot of kids that will just do 3 minus 2. Right? So if you put the negatives in first, the subtraction signs in first, you're not going to make that error. And then x sub 2 is 3. And then x sub 1 is negative 3. What do you have to remember to do before you square? Right here, what do you have to do? Add the opposite, right? Plus, plus. And so I end up with, don't drop off that square root. Question?
Would it make a difference if that one was,
It wouldn't, and I'll show you here in a minute. It won't. I'll show you here in a minute. Let me actually find that difference. And if you think on the number line, how far is 3 and negative 2 from each other on the number line? 5. So 3 plus 2 is 5, right? Squared. Plus 3 plus 3 is 6 squared. And 3 and negative 3 are 6 apart on the number line. So if I reverse these, what's negative 2 minus 3? Negative 2 plus a negative 3 is negative 5. So I'll still get the same answer, but I'll get the opposite sign. And same thing here, negative 3 minus 3 would be negative 3 plus a negative 3, which is negative 6. So it won't make a difference which one comes first. And then go ahead and square them. So I get 25 plus 36. Have you seen those numbers before? Right here and right here, correct? And then I still get the square root of 61. Either one is just as much work, in my opinion, but this one does require you to actually plot the points. Because I'm not always going to give you a graph. I'm just going to give you, here's two order pairs, you find the distance. So for instance, any questions on that before we actually do a few more problems? Okay, so then I'm not going to give you a graph this time. I'm just going to give you the ordered pairs. So example, this is your true example now. Find the distance given. Meaning find the distance given the following 2 points. So your first point is -2, -1. Negatives are evil. They will be your downfall. And +2, +3. What's the first thing that you should do? I would label them, right? X sub 1, Y sub 1, X sub 2, Y sub 2. The next thing that you're going to do is you are going to rewrite the entire formula. Y sub 2 minus Y sub 1 squared plus X sub 2 minus X sub 1 squared. Why would I make you rewrite the original formula each and every time? So that you'll actually memorize it. You're going to use the distance throughout all of your math again. I sound like a broken record now. You keep saying that. It's true. Right, Katie? Thank you. That was a good answer. All right, so I'm preparing my template. Notice that I've rewritten that formula, but I took out the x's and y's. That's huge. If you skip that step, you're going to make sign errors. Even the best of you, the smartest and brightest of you. So I'm plugging in y sub 2 is 3, y sub 1 is -1, x sub 2 is 2, and x sub 1 is -2. This is my blueprint, and I'm just following it. Now all I have to do is do the math. Add the opposite if you have any double signs, and then you complete that. Tell me what you get. And if you're done before others, simplify that radical and give me the decimal equivalency. So simplify your radical and give me the decimal equivalency. So your distance between those 2 points should have come out to be 4 radical 2 if you simplified correctly. Underneath the radical is the square root of 32. No calculator should be used, oh, by the way, because you ought to be able to do those problems with a calculator. You're not going to get one on your test. So I want you to estimate the square root of 32. What do you think it is? What do you guess it to be? 5.7. 5.6, is that what you said? All right, so let's find out. What perfect square is to the left of 32? 25. And so that square root is 5. What perfect square is to the right? Yeah, because if it's 6 times 6 is 36. So how far is 32 from 36? 4. And how far is 25 from 32? 7. So this time we're definitely closer to the right side, right? Unlike yesterday. So it's definitely bigger than 5.5. And so you said 5.6 and 5.7. I would probably choose 5.7. The exact answer is 5.7. So that again. root of, what are we doing, 32? 5.7. I don't know what y'all think. If I round that to the nearest tenth, isn't it 5.7? I can see why you might choose 5, but aren't I going to let you have a range of values? So if the actual answer is 5.7, I'm going to allow you to give me the answers of 5.6 to 5.8. So won't you all, what you told me, be correct? I'm not expecting you to get the exact answer. I'm expecting you to get close to the exact answer or the exact answer. Okay? All right. So pay attention in your homework tonight whether you're giving the exact answer, because this is the exact answer, whereas this is the approximation. So just be careful. Example 2, I have 2 more for you. Oh, hold that thought. Former Girl Scout is always prepared. Yes, I was in Navy Girl Scout. I'm proud of it. What did I say? Okay. Example 2. I hope that wasn't a snide remark. Find the distance given. You do this all on your own. Find the distance given the following 2 points. 0, 0, and 4, -3. Now you're welcome to plot those and use Pythagoras Theorem. You're welcome to use the distance formula. You can decide which is point 1 and point 2. It's your choice. I always like to try to be really smart about which point I choose to be point 1 versus point 3. I like to make my subtraction easy. When you get an answer, share it with those around you. That's a good one. Share, share, share. What'd you get? No need for a decimal approximation, is there? Here's my work. Your work might have different signs than my work. So in other words, if your zeros came first, you're going to have a +3 here, but a -4 there. The nice thing about this is if you do make a sign error, the squaring makes it go away anyway. So you should have a 9 and a 16 here, which does give you 25, which the square root is 5. So there's no decimal approximation. Now if I asked you to write your answer to the nearest tenth, how would you actually write that answer? Technically.
5.0.
Yeah, 5.0. All right, last problem. This one's the hardest to do, and so all you're going to do is use your algebra skills and your knowledge of working that formula. So example 3. Says, find the possible values of A if the points to be given coordinates are the indicated seriously, we have to go through this 2 days in a row, you're not writing anything down. Because next comes a phone call to mama. The indicated distance, you need to write the directions down. If you wait to write them down, then I've already started on another part. So this is not an observation classroom. So you're to find the possible values of A if the points with the given coordinates are the indicated distance apart. And here's what you're given. 5, 3, and negative 2A, and the distance is equal to the square root of 50. So we actually know the distance between the points. It's not a nice happy number. And we know most of the 2 points, right? All you're going to do is the same process as before. You're going to number these as x sub 1, y sub 1, x sub 2, y sub 2. And then that's D. Start with your general formula. D equals square root of y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. Can't I plug into that formula what I know? So I'm going to write it as a template, but I'm going to take out the D and the Y's and the X's. So same process as before. Nothing has changed except how we do our final solution. So there's my minuses. And I'm going to plug into here my value. So for D, I'm replacing it with the square root of 50. And then I'm going to put in for y sub 2a. That's what I'm going to solve for. Y sub 1 is 3. X sub 2 is negative 2. And x sub 1 is 5. If here I had double negatives, I would make sure that anywhere where there's double negatives inside the parentheses, usually do a plus plus. Well, I don't have that. So I'm going to go ahead and start to solve. What's the thing that's the biggest problem of all for you? The what? How about the radicals? If the radicals were gone, wouldn't it be easier to solve? You've learned how to get rid of a radical. How do we get rid of it? Yeah, can't I square this side? And can't I square this side? Won't that get rid of my radical? And I think my notes online are slightly different, but we'll still get to the same place. So if I square this radical, don't I get 50 equals? And if I square this radical, I get parentheses a minus 3 squared plus, and here I am going to add the opposite, plus a negative 5. So what's negative 2 plus a negative 5? Negative 7 squared. What would you like to do first? Yep, we'll square the negative 7 first. So 50 equals a minus 3 squared plus 7 squared is 49. Yeah, we're going to subtract 49. We're going to ignore this for right now. So most of you are probably going to subtract 49. You're going to find out later that you're going to have to move this 1 over here. You'll see why in a minute. You get 1 equals a minus 3 squared. We've actually learned a couple of ways to solve this. My online notes are different, but there's an easier way to solve this than what my online notes say. Do you remember what we do in this situation? You have a squared here and not here. It's a lot easier if you remember what the shortcut is. If I take the square root of both sides, what do I have to do when I take the square root of a number? You have to do plus or minus. So for our purposes, first I'm going to use the symmetric property, and I'm going to flip-flop this. So I have a minus 3 squared on the left and 1 on the right. You'll see why in a minute for my madness. I don't want the plus minus on the left. Then we're going to take the square root of both sides. If you're going to use this method, you must remember this plus minus when you take the square root of a number. What's the square root of a minus 3 squared? So we get a minus 3 equals plus or minus, what's the square root of 1? 1. How do you solve for a? Add 3. And remember, you're adding 3 in front of the plus minus. Remember this from unit 9. Okay, so then I have A is equal to 3 plus or minus 1. So here's my possible values for A. What's 3 plus 1? 4. And what's 3 minus 1? 2. So those are my values that A could be. I could have two different ordered pairs from the ordered pair of 5, 3 that has a length of the square root of 50, so long as this x value is negative 2. I could go negative 2, 4, or I could go negative 2, 2. Now let me just show you what my online notes look like so you can see the alternate view. So my online notes, I did not square both sides first. I just went ahead and I multiplied this out. Remember, it's a squared binomial. It has a middle term. You use your pattern, or if you do a minus 3 times a minus 3, you get 3 terms. That's 49. It combines with a 9, and you get a 58. Then I squared both sides and got rid of the radicals. And then you have this quadratic. So you need to have one side set equal to 0. So I subtracted the 50. And then you see me factoring. It's a lot more work, isn't it? So the factors of 8 that add to give me 6 were 2 and 4. My 6 was negative, so they're all negative. I am grouping and garbaging here, but I could have used a shortcut and just put minus 2 and minus 4, correct? Do I get the same answers? Yeah. So if you can recognize this shortcut right here, this is a lot easier work. Just a thought. All right, any other questions?